Good morning, everybody. Thanks for joining us today at the webinar. We're here with Michael and Jacques of GoodWe to talk about their hybrid and string inverters. Let me just, before we get started, just wanted to mention that this webinar is being recorded. We'll send it out afterwards, and feel free to put any questions you might have in the Q&A section down below. So real quick, I'm just gonna share my screen. All right, can you guys see that okay? Jacques, Michael?
Yes.
Okay, awesome, cool. So we are Supplied Energy, and just want to share a little bit briefly about what we can do for you. So again, today we're here with Michael and Jacques of GoodWe, and I'm also joined by my colleague and president of Supplied Energy, Kyle Smith, along with Valerie and Mallory as well. They work part of our team. Here are some more faces of the Supplied Energy crew. These are the folks that make our team run so smoothly here. We currently have locations in Austin, Texas, Catoosa, Oklahoma, Greenville, Illinois, and Noonan, Georgia. That's basically the Austin metro area, Manor technically, the Tulsa metro area, and St. Louis, as well as Atlanta. So this is the services we offer and who we work for. So we are a wholesale distributor at the end of the day, but we like to be more involved and as involved on projects as much as we can. We work for installers, developers, drillers and loopers on the geothermal side, home and building owners, the electric utility, architects, engineers, you name it. We'll like to help you out and find a solution as best we can. These are our product categories that Supplied Energy offers. We have HVAC as well as the power products, which is the section what we're talking about today with GoodWe. We have energy monitoring and load management, and water heating and piping fabrication as well. So we do that in a 4-step process. Step 1 is tighten the envelope by use of spray foam, cellulose insulation, vapor barriers, things like that. Really reducing those energy loads up front to make your home more efficient. Step 2 is install an electric heat pump, whether that be air or ground source, geothermal. Mini splits, we sell products in all these categories. The 3rd step would be to generate your own power with solar. We sell solar modules, inverters, racking, balance of systems, every component necessary for a solar project. And so once you generate that power with your solar, we store it in a battery and use that power for later use, or store it for later use rather. And then so the energy monitoring and load management section of our company also ties into that as well, just so that we can have a better idea of what our home is doing and how we're using our energy. Here's a quick example of a home. This is what we're trying to accomplish as a company. So we're tightening the envelope with good windows, good insulation, vapor barriers down below, keeping that envelope nice and tight and clean, good air in the house, cold air, warm air out, whatever you want to call it. We store the energy in a battery from the solar, and we also have a geothermal heat pump in this home. So this is like a whole package and what we're trying to achieve at Supplied Energy. And so again, like I said, we're here with GoodWe today. Wanted to talk with them a little bit about their sales support, their product availability, their product line, and why we went with GoodWe and chose to take them on as a good inverter option in space. And again, yeah, feel free to put down any questions you might have in the Q&A. And that's all I have for you guys. But Kyle, did you have anything you wanted to add?
Oh, not exactly. We're pretty ready to hand it over. But I'm really looking forward to having the products in hand. And, as far as relates to string inverters and grid tied and hybrid inverters and AC coupled inverters, as well as commercial. So I've been watching GoodWe in Europe and Asia for some time, and as soon as I saw that they were in North America, I jumped on it and contacted Michael, and from there we've had some really good conversations. I've really liked what I've heard about the product, And I think there's a lot of holes in the marketplace right now that are really going to be helpful for their products. And so with that, I'll shut up here and let them take over.
Great. I'm going to go ahead and stop sharing my screen. So if Jacques or Michael, you want to take over?
Sure. I'm sharing it this is Jacques. I'm sharing it, but Michael will begin with the first 3 slides.
Yeah, super. Well, thank you, supply team, for supply energy team for the introduction. When we first had a discussion with Kyle, I was really excited about their offerings, and since GoodWe also wants to offer complete solutions and really match the needs for homeowners, I was very quickly on board and very excited to be with the team. Joe, can you go down a bit? Okay. So I'm Michael. I'm Michael Mendig. I'm the country manager for GoodWe. I started a year ago. Really excited and by the company, by the quality of the products, and the full commitment to the U.S. market, and the full commitment to create a future with smart energy and complete home solutions. So we exist since 2010. Focused on PV and storage inverters, and over 38 gigawatt installed. That's like over 38 kind of medium-sized nuclear power stations. So it's a lot of power that we have installed already. Over 4,000 employees, 700 at R&D. So that's quite a lot. In R&D, we have now 10 international branches, and one of them is the US. That's us. Go next one, please. Okay, we started in Europe. Then we moved to other areas like India, Australia, and Brazil, and Southern America. And we were consistently basically top-ranked inverters. We are right now on the top 5 of the global inverter list, and that's just with residential and C&I products. We're also looking into the utility scale market. In the Europe, we are a little bit faster, and we will at some point in the US also be offering utility products. So we started the subsidiary in 2021, last year, and the range now we are looking at Canada, US, even down to Puerto Rico. Thank you. Here we are. This is our team. We're starting with the residential products, then residential and storage, then C&I. We are fully UL, NEC, CEC, and IEEE certified, also for next year, of course. Our team is focused on sales. We have pre-sales, which helps you if you need stringing help, if you need some information about the product, how do I apply it, I have these panels, and so on. Then Jock Patterson is the absolute perfect person that can help you with that. Then we have a sales team, a marketing team. Our marketing team will be working closely with Supplied Energy, with our partners here, to create the best information for you, everything you need, also down to B2C literature. After sales team, I'll talk about it separately. And of course, we have some little bit of finance, but we try to be quite lean as possible. The main office is in Denver. We got a technology center in Denver as well. This is our after sales service and repair center with RMA units. And we also have a non-bonded warehouse, which means you can go to the ramp and pick your products up right away. They're all already went through customs and everything. They're in LA. We have available stock, but the stock that you might be interested in, string inverters, are going to be finished production next week and shipped, and hopefully in mainland mid-January. And then available. And then there will be a continuous flow of new products coming from headquarters. We have it's all right. We have a new service center here. We are working together with Linktronic in Denver, in Aurora, actually. It's a contract manufacturer. This is the service center for North America. And what it means, we have RMA units. So if a unit fails, you send it to us. You got trigger the RMA process, and we send you a replacement unit, so it will be available. We do have RMA stock here in Denver, which we can replace readily. Right, regarding support. So support is, as you know, very important. We do have a couple tiers. Tier 1 is a global support. You call this phone number. And tier 2, if it's the problem is more hectic, it's a more complex problem, we can help out of Denver. We have 2 people, the technical service director, Adam Cordova, and senior service engineer, Dustin Billings, can help you on the phone. Also, what we do when you first buy our product and want to do an installation, we can give you a quick start program. That means we spend about 1 hour with you. It's not too long to explain you how you do the first install, how you do commissioning, how you use the apps, how you also register into the monitoring system called SEMS. So we help you, and also we help you on the phone during the first commissioning. And of course, our salespeople will be in touch with you. Thank you. Next time. Okay, this is Chuck's area. Thank you so much.
Thank you, Michael. I'm going to show you today's product, and then we're going to focus in on the main topic, just the PV inverter. But we actually have 3 inverters. They all look the same here. The chassis is the same power classes, but here are the differences. The first one is a PV only inverter. Second one, a battery only. You combine those 2 together, the functions, and you get the hybrid inverter. The hybrid inverter is something we'll talk secondarily about. And of course, I want you to know that the battery inverter is there for AC coupling if you're retrofitting a system. But the main topic here is the PV inverter.
Hey, Michael, real quick, can you just point out what the acronyms mean in these battery series? Or the AMS,
Yes.
or ABP, just for me.
Sure, very good. So starting out with the A hyphen, that means America only.
Okay.
These are UL listed, right? In the rest of the world, it's all IEC. So designed with wiring boxes for conduit, right? Not just clicking in MC4 connectors or something. The MS stands for medium solar. So it's not a small PV inverter. It's medium range from 5 to 9.6 kilowatts. The BP stands for, on the second one, battery power. That's where it gets its power from, the battery, not solar, right? It's only battery. The third is energy storage, saying I can take and store energy from PV, grid, and use it, whether for backup, time of use, etc. And we'll talk about some of that.
Got it. Thank you.
So across those 3, there are 6 power classes from 5 to 9.6, with the common classes being 5, 7.6, and 9.6. Inside the inverter, so included, already wired in the inverter, so there's no need for an external box, is a smart meter. Inside the packaging for the inverter is also a set of CTs. So you can install those. For the PV inverter, it's not required. It is recommended. I'll explain that in another slide. And again, across all 3, you can choose to use the included Wi-Fi communication module, which we call a Wi-Fi dongle. It plugs in the bottom, and it's represented in the bottom right in the red circle. It's the last thing you'll do after you would do installation, but right before you start commissioning. Other forms of communication would be a cellular or LAN connection.
Does LAN require anything special? Just anything on that front?
Yeah, so good question. You, instead of plugging this dongle device you see here, you'd be plugging a different one in, but after sales would send that to you, knowing that that's what you need. We know at the residential level, it's not very common, so we don't throw one of those in the box. But if you need that, that's great in your quick start conversation when you first talk to support after sales are called. They will ask about this. And if you say, well, for this install, we're actually going to use a LAN connection. Great, we'll send you one in advance of you going out there.
Great, got it.
So on a PV system, it's very basic compared to like a hybrid. So we understand that there's just power flow from the PV into the inverter and back out on the AC side, whether to feed loads or extra power going to the grid. And of course, grid power can come in, feed the loads, and be sensed by the inverter. Because this is a PV inverter, it has to sense the grid, right? It has to shut down if the grid goes down. So it's an on-grid inverter. The dotted blue lines indicate these virtual connections, right? We have connections through our Wi-Fi dongle, for example, to our SEMS system. That's our monitoring in the cloud system, which you can access via an app or on your computer, going to the website, that portal. And another way of connecting to the inverter is through our commissioning app and configuration app. So there are different ways to control and view what's going on with the inverter. What's not pictured here is that, as I mentioned before, there's an embedded smart meter with CTs. The CTs lines would run out somewhere close to the grid connection, be able to observe how much energy is flowing out to the grid, and what isn't flowing out that you produced must have been consumed. So that kind of consumption and export information is available on the SEMS platform. On the PV side, what are the advantages, not just to our PV inverter, but to our hybrid inverter? Because our hybrid inverter doesn't lose the PV advantages. Often with some other brands, if you take their PV inverter compared to their hybrid, or just look at their hybrid, it doesn't have the full spectrum of PV specs you'd like to see. Ours are the same for the PV and the hybrid. So starting with the number of MPPTs, or maximum power point trackers, that is the number of strings you can optimize. Each string will be optimized because there are up to 4 MPPTs, so you can do 4 roof faces. In the residential world, it's unusual to go beyond 4 roof faces. So generally, you're always optimizing each string. And if you have little or no shade, then there's no need for an optimizer. That's all done within the string inverter. You can also oversize to 150%. Very useful if you're doing east-west roofing, right? You're only getting half the system exposed to the sun in the morning and late afternoon. So it's great to be able to do oversizing. If you do have small roof areas like up here, you could stick as little as 3 or 4 modules, and that would be fine because you can run at a very low voltage and still have the string operating. In fact, the whole inverter operating is a better way to put it. You don't need a high voltage to start up, but you always want to shoot for high voltage, just better performance. Another thing unusual to this inverter is that it is able to handle 12.5 amps of operating current. This is higher than most inverters out there because GoodWe sees the increase in current from PV modules. The newer modules, sure, they're higher power, but a greater percentage of that power is coming in the form of current. So you need to have inverters that can handle that. Otherwise, the inverter is going to clip and you're going to lose power. In addition to an embedded smart meter, rapid shutdown is included in the form of a transmitter choice between a Tigo transmitter or an AP Smart SunSpec transmitter. You choose by specifying that on an order, which one you want. If it just happens that you're not going to use either, through the quick start training, you'll be told how to disable it. Pretty standard is a built-in PV disconnect. Installation here is being shown not to really give you a step-by-step of how to install, but rather to show you that this should be pretty familiar, right? You're putting up with fasteners a mounting bracket and you're hanging the inverter. The inverter comes with a template. It's the first thing you pull out of the box. So you don't want to throw that away. That's your template, right? Makes it much easier to line up the brackets. And then you hang the inverter, and you can even put a lock in it for anti-theft. The inverter is going to normally be standing up, but it could be reclined back, I think 15, maybe 20 degrees, so it doesn't have to be perfectly vertical. Because we're a UL wiring box here, there are plenty of holes for conduit. Any holes you're not using, of course, initially are covered. So when you get this inverter out of the box, it's NEMA 4X rated. And as soon as you take one of these covers off, it no longer is NEMA 4X rated, right? You have to put conduit in with the proper connectors and return it to that NEMA 4X rating. Ideally, you run conduit, say from the roof, coming down and back up. If you come in the side, and there are side openings, one on each side, you always want to be careful about any water intrusion. So you want to use electrical putty or have a drain at the bottom of your elbow, your LB. And again, any of these questions, these details, that's what I'm here for before you go full bore designing with this inverter. If you have questions, pre-sale support. That's, we're trying to offer more than just a product. Just like Supplied Energy provides the whole set of services, we're trying to do the same thing for your experience with string inverters. So when we look at the whole inverter, the only part you're touching is the lower wiring box. Everything up above, is there anything wrong in there? We're RMAing the unit. There's no opening this up. So we want the experience to be very simple and quick. In this illustration, we're showing what it would look like for wiring a PV inverter. Obviously, if you're doing a hybrid, there's a lot more connections, but I'm going to show both. So wiring the AMS, again, this is America only, medium single phase. Well, you can look at it as solar, but it really stands for single phase, because we do offer a 3-phase, right? We're going to introduce you to the CNI inverter at the end of this presentation. So as a PV inverter, we have PV inputs, and we have up to 4 MPPT. So that's why you see 4 sets of connections. On the grid side, the AC side, similar, again, screwless, spring-loaded wire terminals. So this means you can just slide the wire in if it's solid or rigid stranded. If it's fine stranded or somewhat less rigid stranded, you'll likely want to put a ferrule on it. And those ferrules exist in the inverter box, right? Our little accessory box. You'll find a bunch of ferrules. With that properly crimped, it's not only preventing the splaying of any strands as you insert it, but also means you don't need to have a tool to open up the throat of the spring-loaded terminal. You can just push it right in. It also, over time, reduces the oxidation. And so you get a better contact, less resistance over time by using ferrules. That was power wiring. Now we got comms wiring, which is really just the CTs. Remember, the Wi-Fi module just plugs in. The only thing you're doing on a PV inverter is for external comms wiring are the CTs, which will wrap around your L1 and L2. And then you'll do in the commissioning process a meter test to make sure all that's done correctly. The real benefit of CTs is, again, on the SEMS monitoring platform to see how much of the energy is going out to the grid, how much is being consumed. But you'll also want to do this if you're in a utility or an area where you can't export, or you have to limit your export. You need some method of doing that. So the CTs give you that control. I'm here showing, not to memorize all the details, but just to indicate here that the PV inverter and the hybrid inverter share the same PV characteristics, right? Just showing that you didn't lose things when you try to do it all in a hybrid chassis. And that's because we started with a hybrid chassis and went backwards to the PV. So we made sure everything fit in there. So on the battery side, now we're getting away from just being a PV inverter, but for our battery only or our energy storage inverter, the hybrid inverter, you have these features. High voltage, that's the number one thing that is usually new to someone. We do high voltage connections to batteries because high voltage is more efficient. When you run high voltage wires at high voltage, you have less loss, so less voltage drop. Also, it means you're using thinner cables, so that's less copper, less costly. If you're trying to do an inverter outside of a garage and then the battery on the inside because of operating environment, you're not supposed to have the battery in that cold environment. Try running 4-aught cable through walls. It's much easier using number 6 and number 8 THH10 because you're using high voltage batteries. So another benefit of using high voltage batteries is distancing the inverter from the battery if necessary. We offer both AC and DC coupling because if you're using a battery only, that's ideal for AC coupling or retrofitting. And then DC coupling is for the hybrid, right? We're going to have the PV and the battery all going through one inverter. The 50 amp charge discharge, you're not always doing 50 amps. You're capable of doing that, right? If your inverter is rated for less, you're not necessarily going to be doing that. The point is that the inverter is able to handle up to 50 amps. That means that if the battery is capable of doing it, there's no bottleneck. Often the bottleneck in an ESS, an energy storage system, is between the battery and the inverter. If you pair it with a battery that is designed to be compatible with it, you'll get the high power throughput and the inverter will be able to handle it. So that's what we paired with. More on that a little bit later. Operating modes. If you're using a hybrid inverter or a battery-only inverter, you may be getting it just for backup and saying, I want this battery charged at 100%, keep trickle charging it, ready for an outage. However, while most people want that insurance there, that they've got backup, there are often opportunities to save money or even look at as making money by dealing with time of use rates, where you want to avoid consuming from the grid during peak time, so you consume from your battery. You can program the battery to just charge at those peak periods. There's a few other options there, like export limitation, all falling under trying to control when you use your PV energy, not just when it's being produced, but being able to store it for when it's ideal to use it, including demand response programs that certain locations have. So I'm just showing a couple batteries here as examples. We're not saying that you have to use these. In fact, we want to talk about our battery. And that's something that's coming up at the beginning of next year. So you have time to learn about it and plan for it if that's of interest, and we can get you ready at the beginning of next year for that. If you are doing this generation inverter, it is designed for high-speed switchover. That's transfer time to the backup mode. So less than 10 milliseconds. That means you don't drop loads. This is if you're using an essential loads panel. If you're going to full home backup, then you often have these separate backup gateways, and they take longer to switch over. So you'll want your most critical loads on a UPS. And this is true with most any system that is doing full home backup. It's hard to go at a transfer rate that's below 10 milliseconds. So if the key is fast transfer time, this is the inverter, because it's got a built-in ATS that switches in less than 10 milliseconds if you're working with an essential loads panel. So what happens in the hybrid? Well, the sun is out, you're getting energy coming into the inverter, and it can feed the battery if it needs charging, your essential loads panel, or your main service panel of loads. It could also go out to the grid if there's extra. But now we're at night. What happens? Well, you still can get from the grid, but your battery could supplement, especially if you're in a peak time of use period. So power flows can come into the inverter from these two sources. However, if the grid is out, then it's up to the PV and battery to supply the essential loads. And that's just the different sort of flowing you'll see occurring depending on the operating status. The only thing I want to show here is, again, something about the fact that high voltage solar input is going into a high voltage battery, right? There's very little need for DC boost. The MPPTs that we're used to maximize your solar production are also maximizing the battery charging. So you have very efficient movement of solar energy in that doesn't need to be consumed, that can be stored, very little conversion, so very little loss. If you are wiring the hybrid, it's a lot more going on. So I'm not going to go into all the little connections and stuff. I'm just showing there are a lot of potential connections for a hybrid inverter. For commissioning, after you've wired everything, you plug in, for example, the Wi-Fi module or dongle, as we call it, and then you start up an app, our configuration app here called PV Master in this case, and you basically configure the inverter to know what is connected to it and how it can communicate to SEMS, a monitoring platform. That is, how can it find the homeowner's router and call home, as we say. So that was the residential line. Quick overview of the C&I line here. It's new to the US, this SMT US, but it is not new. Its electronics are not new to the world. So in previous incarnations around the world, it has had a lot of test time. And so this is considered a proven design. It's just now a white box for the US with the UL wiring box below. The features of this, it's a 480 inverter, 480 volt, and it's good for delta or Y, a secondary winding configurations. So that means basically it can take it with or without a neutral. There are some additional perks. It has surge protection on the AC and DC side. It has AC and DC switches. It also has a very intelligent AFCI, considered what we say intelligent because it's AI based. It keeps learning. So it's very sophisticated AFCI. There will be options in the future for IV measurement, so you don't have to disconnect wires to do your IV tracing. And we were even considering if it's still an issue at all for some people, PDI, that's a potential induced degradation, or PID, mitigation. We have a method to mitigate PID if that's an issue. I talked about our residential inverters being able to handle these 12.5 amps. For this, we're talking 15 amps per string. Now, if you happen to get in a module, and they're out there, and they will be out there, they're more than 15 amps, it just means you're just doing one string into an MPPT rather than two. So the MPPT is 30 amps overall. So that means we can handle very powerful modules. Most of them are still going to be under 15 amps, so you're going to be able to put two strings per MPPT. And you have 5 or 6 MPPTs, whether you're doing the 50 or 60. So the two sizes are 50 and 60 kilowatts. So that represents the CNI, and I'm happy to take questions. I was going to talk about support here, what kind of support you get. Michael covered this. Again, I'm the pre-sales, right? I'm going to help you. So you avoid the chance of being stranded in the field, choose the wrong power class, don't do the right string sizing. I'm here to help you prevent those. And then you'll get the quick start training to help you the first time, customized one-on-one training on your first install. And then after sales, the tier 1 and 2 tier support that Michael mentioned. So I'm going to say thank you here, but I'm certainly not done because I'm ready for Q&A.
Sure. Well, thank you. Actually, one thing I'll note is that we're used to doing at Supplied Energy, we're used to doing the first training for a company or for a customer of ours with their first time with a product. And you're the first company we've ever ran into that is offering the first time support startup opportunity. So that's awesome that we're doing that together. We do have one question though on warranty, and then I have a secondary question to that. This is a repeat that you did mention, and I think, and there's probably a question probably came up before you answered it here earlier. But what is the warranty, and what is there an extended warranty option?
Yes, so we have a 10-year warranty standard, and then you can add a 5-year or even 10-year, +5 or +10. Yeah, and we handle that all together with Supplied Energy.
Okay, Harrison, you had some questions for me on while we're waiting. You know, everybody's I would suspect has some questions, but typing them out. What about the lead time, Harrison? You asked me some questions yesterday when we'll have product in hand.
Yeah, right.
Okay.
I was curious.
Okay, so the units that you ordered for stock are going to be finished next week on the 15th and then shipped. So they arrive in the US, in LA, sometime mid-January, I'm sorry, or the second week of January, and then from there ship to your warehouse. And
Yeah.
and then we're going to continue stocking up our warehouse. There is 8 containers going to be coming. This is going to be the first one. We're going to be stocking up our warehouse in LA, and from there, from the warehouse, the lead times we commit to is 2 weeks. So some of our products are already available, like the hybrid inverter got 2 weeks. Yeah.
Awesome.
Yeah, so I mean, knock on wood, we'll have ours February 1st or somewhere in there. We won't be able to get anything other than hybrid inverters, which I will say are very, in my opinion, a very affordable hybrid inverter that we can actually place. We can use the AES
AES.
in place of the AMS. And so the homeowner would have, I'll call it inverter infrastructure
Correct.
ready to go for batteries down the road. But it's really, I thought, in my opinion, not a whole lot more money for the hybrid inverter. And whenever the marketplace is so thin right now for string inverters.
Yeah, and we have a when you commission it as so-called battery ready. So it's basically ready for a battery, but it does not have the hybrid functions basically. But it's basically a full PV inverter.
We have another question. Can your battery increase the battery capacity beyond 32 kilowatt hours?
With the next generation, our first battery coming out at the beginning of next year, and our next generation of what we're calling right now the AES, you're going to be able to go beyond 32 kilowatt hours because you're going to be able to stack a lot of batteries. And so I don't know what the number is, but I believe that you can do at least 3 battery stacks, and each battery stack is probably I can't remember,
20.
Michael, like 20. Yeah. So that's
19
60
something.
Yeah, 19.7. So close to 60 kilowatt hours for a single inverter. So if you did 2 inverters, you get double that.
Gotcha.
And plus you will be able to do in parallel 3 inverters. So if you get the next generation that is about 11 kilowatt, then you can do in parallel 33 kilowatt, and each inverter has then 60 kilowatt hours in parallel batteries.
Jacques, would you mind going back to that hybrid wiring slide for me for just a moment? I just want to check that out a little bit more.
Sure, no problem.
That was a helpful diagram.
This one that has lots of details.
Yeah.
Yeah. Do you want me to kind of step through it quickly, or is there something?
Yeah,
particular?
if you don't mind, real
Right. So it's pretty straightforward when we talked about the PV one, that you've got PV strings coming in, up to 4 strings here. And I'm assuming you can see my laser.
Yeah.
And then the next over would be on the DC side. The left side is a battery input. And so the same lines are used for input in it, right? Charge and discharge. But there's also a communications line, the one that's marked as BMS, right? We have to control, we have to talk to the battery. This is not a dumb battery. We need to be able to say, it's for safety factors, turn your voltage on. I mean, this is potentially, you know, 400 or 500 volt battery. These are allowed at residences because of these controls. That's when the NEC says, I make an exception. I'll allow you to have over 100 volt battery because you have a smart battery. That's why our batteries have these communication lines. They have to be smart, and therefore they're safe. And then in the middle, obviously, is that little Wi-Fi dongle moving over the auto transformer. So the auto transformer, normally a PV inverter, and therefore also a hybrid inverter, wants to push out 240 volts. But if you've got a backup circuit that has 120 volt circuits on it, you need 120, you need a neutral. Well, when we lose the grid, we lose the neutral. So we have to derive a new neutral. This becomes the power supply. The battery and the inverter become, this ESS becomes the power supply, and a neutral has to be derived. And that's what the auto transformer does. And the nice thing about an auto transformer, particularly this one, is it does it very cleanly. And it allows you to have imbalanced 120 volt circuits. So if you have an essential loads panel that has 120 bus bar and another 120 bus bar, if for some reasons people are using only the loads on one bus bar in backup situation, it isn't a problem. It can be imbalanced. If you're not using an auto transformer, then you have to worry more about balancing. That's why this is an ideal solution for essential load backups. The next thing over is, go ahead and interrupt me if I'm not answering your questions, but is the essential loads diagram where we have example of 120 and 240 volt, right? Because you can still do 240 volt backup loads. You always want to consider, though, the startup amperage, right? It might be lock rotator amps or something that you always have to consider what you're connecting to the essential loads. But remember, we do have a pretty high output. So if this inverter was a 9600 watt inverter, we can always push out 9600 watts with the right battery. We can always push out 9600 watts to the backup circuit. But for the first minute, we're up to 60 seconds, we'll push 20% higher than that. So we'll be doing something 11.52 kilowatts for up to 60 seconds to make sure that all the loads start up. On the AC side, for normal grid connections, we have L1 and L2 and the neutral, and we are attaching CTs, the yellow communication cables, to monitor that flow. And that should cover really everything here. The ones going down here are just representing the main service panel loads. Essential loads down here, main service panel loads.
Well, I mean, this is actually a very good diagram, but I almost think we should probably plan a couple more webinars in series that we'll probably do in the first quarter and get a lot more detail about what kind of options we have. And after talking with Michael too, I think we'll have some partnerships in place on load management as well, and battery options that I think will, because I feel I'm the type of person, until I know everything on a concept, I feel like I know nothing. And but I'm becoming more and more well versed with hybrids. So anyways, I'm thinking that we probably should dive into that deeper in another webinar yet here in the early first quarter. And and then the other thing I want to ask you about I mean, as far as I know, specifically Illinois and RGM. Michael, did you have some notes on RGM as well?
Yeah, so we don't have a certified revenue grid meter. We have a monitoring unit, smart meter embedded inside, and also transducer. for a pitch shutdown, but you would have to use an external one with the new generation coming. Hybrid inverters, we will have, when they come sometime Q1, Q2, we will have hopefully a fully certified revenue grade meter inside there. Yeah.
Oh, okay, gotcha. Awesome. Sorry, I put you on the spot on that.
No
I
problem. That's okay.
misinterpreted what you said. Sounds
That's why we are
good.
here. Mhm.
Right on. Well, we haven't had any more questions come in, and I feel that I would really like to get into more of the hybrid installation and expectations of the homeowners and outputs and what everything we're able to do, and maybe save that for a webinar too. Anyways, does anybody have anything else to add, or any other last second questions here or anything?
No, you're right, Kyle. I think we could talk about this for quite a while longer, but we should just do another webinar and get into the nitty gritty.
I think so too, because I was starting to have a page of questions that I was going to start asking myself. So I'm thinking that's a great opportunity for a longer session on, and yeah, so if anybody has any questions or is ready for some pricing and again on availability, some strategy, please let us know. Our generic email address is support@suppliedenergy.com, and my email address is kyle.smith@suppliedenergy.com, and please reach out with any questions or any sort of information related to GoodWe that we can help with. So, and thank you very much, Michael and Jacques, very much for your time, and looking forward to working with you a whole lot more.
Okay, very
Thank
good.
you, Kyle, and Supplied Energy. Yep.
Thanks a lot.
Thank you.
guys.
Bye-bye.
Appreciate your
Okay.
time.
Bye.